Hello, welcome to Prajim Technologies. I'm Venkat. This is part 53 of SQL Server. In this session, we'll learn about second normal form, also commonly referred to as 2NF, and third normal form, which is commonly referred to as 3NF. Before continuing with the session, I strongly recommend to watch part 52 of this video series, where we have covered the basics of normalization and the first normal form. So when do we say a table is in second normal form? A table is said to be in the second normal form if the table meets all the conditions of the first normal form. So the table has to be already in the first normal form. And then the table should not contain any redundant data. So if the table contains any redundant data, move that redundant data to a separate table. And then establish the relationship between the two tables using foreign keys. So let's understand this. Let's see a table that's not in second normal form, and let's see how to change the design in such a way that those tables meet the rules of the second normal form. So if you look at this table that I have here, which has got employee ID, employee name, gender, salary, and then we also have department name, department head, and department location columns. Now let's assume in my organization I have 100,000 employees. So obviously in this employees table I'm going to have 100,000 records. But let's say I only have two departments in my organization, IT and HR. Okay, so if you look at the department, if you look at this table, you have employees data and departments table data joined together in a single table. So obviously, since we know that in my organization I only have two departments and then 100,000 employees, for all the 100,000 employees, this IT and HR, columns should also be repeated, in the sense, we know that there are only two departments, and the department head and department location does not change on a per employee basis. Even if I have 200,000 employees in my organization, IT department head is going to be John and its location is going to be London. And similarly, HR department's head is going to be Mike and the location is going to be Sydney. They are not going to change on a per employee basis. But then since I'm storing these three columns within the employees table and there are 200,000 employees in my organization, I have to repeat those columns for every row. So obviously, what's the problem here? This data is redundant, and we know that because of data redundancy there are several problems. What are the problems of data redundancy? Obviously, disk space wastage. You are unnecessarily repeating department name, department head, and department location information for every employee that you have within this organization. In a bit we will see how to break this down into two tables and then reduce this redundancy. But then let's understand the problems of redundancy first. So obviously, disk space wastage, and your data could become inconsistent. How? Let's say for example, I want to update IT department's head name, and let's say there are 50,000 employees in the IT department. Now I updated the department head name maybe for 45,000 records. In error I forgot to update 5 records. So for those 5 records, the IT department head will be the old person, whereas for the updated ones it will be new person. For example, let's say I changed John to Josh, the IT department head, but I forgot to change it in this row and in the last row. And when we look at this data, okay, here IT department head is Josh, but here it is John. So is your data consistent? It's not consistent. And why are we in such a situation? Because you have duplicated data. Somebody updated few rows, but they forgot to update the other rows, which is actually leading to data inconsistency. So redundant data can also lead to data inconsistencies. And obviously your DML queries, which include insert, update, and delete statements, could become slow as well. Why? Because there are large number of rows to process. So obviously if there are 100,000 employees, we have 100,000 records to update, as far as the department head and department location are concerned. Okay, but on the other hand, if we move this redundant data into a separate table, let's see how to split that. So what we are doing here, we are splitting this table into two. One is TBL employees, which is going to store employees information. The other one is TBL departments table, which is going to store department information. So here I have department name, department head, department location, and then to uniquely identify each row I have a primary key here. Now since I have only 2 departments within my organization in the TBL departments table, it's enough if I store these 2 rows. And then if you look at the employees table, the regular columns employee ID, name, gender and salary are present. Employee ID, name, gender and salary are present. And then we have this additional column called department ID, which is nothing but the foreign key. So we are using this column to establish the relationship between employees and departments table. So if you look at the rules, move redundant data to a separate table. So this department redundant data, we are moving it to a separate table. And then we are creating the relationship between these 2 tables using the foreign key. So we are satisfying the third rule of the second normal form. So this table design is now in second normal form. So obviously we don't have a disk space wastage there. Before this normalization, we were repeating 3 columns. Now we are just repeating 1 column, and we have to do this. We cannot completely eliminate data redundancy. Okay, because if you remove this department ID column from this employees table, you will not know which employee is belonging to which department. So we need to have some amount or some level of redundancy. Okay, so we've broken this down, this table into 2, moving the redundant data into departments table and establishing the relationship between TBL employee and TBL department using this foreign key department ID. So now this table design is in second normal form. Obviously we don't have disk space wastage, we are only storing 2 rows, and your data will not be inconsistent anymore, because if you change the department head name, you'll have to do that in this table. You either will do it or you don't do it. It's not now a matter of updating a few rows and not updating the others. And then when you join this departments table with this employees table, obviously people who belong to the same department will have the same department head and same department location. And your DML queries can also be faster, because I just have 1 row to change if I have to update a specific department. But whereas in this case, if there are 50,000 employees belonging to IT department, then probably I have 50,000 rows to update. Okay, so our table is in second normal form now. Let's say about third normal form. So a table is said to be in third normal form if the table meets all the conditions of the first and second normal form, and then it does not contain columns or attributes that are not fully dependent upon the primary key. Now when we are talking in terms of tables, we call it columns, but when we are talking about entity relationship models, we call them attributes and entities. But here we'll talk about columns and tables. Okay, so a table is said to be in the third normal form if that table does not contain columns that are not fully dependent upon the primary key. Okay, what do we mean by this? Now if you look at this table here, employees table, I've got employee ID, name, gender, salary, and then there is another column called annual salary, and then department ID. Now department ID, except annual salary, all the other columns are fully dependent on the primary key. What do we mean by that? If the primary key changes, let's say instead of 1, 2 here, so obviously the employee changes, Pam, and her gender changes, her salary changes. The annual salary also changes, but then this is not fully dependent on the primary key. This annual salary is also dependent on the salary of the person. For example, if my salary is 500 per month, my annual salary is 12 into 560,000. Okay, so this one is actually dependent on salary. Annual salary is dependent on salary. It's also dependent on the employee ID. But then it's not fully dependent on employee ID. It's also dependent on the salary. Okay, and then if you look at this, is there a need at all to save this annual salary? There's no need. It's a computed column. On the fly, in your query, you can actually compute the annual salary of an employee. So we don't have to store those columns. You can say computed columns, or in a way you can also tell this column is not fully dependent on the primary key. It's also dependent on the salary. So if they're not fully dependent of the primary key, then you can either remove them or you can move to a separate table. Okay, moving to the separate table, we'll talk about that now in the second example. Okay, so if you look at the second example, so this table is not in a normal, third normal form. So what you can do to make this table in third normal form is remove that column completely from this table, because why? We can compute annual salary. Now if you look at this table, this again, which has got employee and department details. Okay, so every employee has got department name and department head. Now if you look at this, employee name, gender, salary, and department name, they are dependent on the primary key. Now if you take 1 as the employee ID, he is Sam, his gender is male, salary 4,500, and his department is IT. And department head, this also depends on employee ID. When the employee ID changes, okay, department head is Mike. Okay, so it's also dependent on employee ID, but then it's not fully dependent, because department head is also dependent on the department name. Okay, wherever you have IT, it's going to be John. Wherever you have HR, it's going to be Mike, the department head. So this department head, it's not fully dependent on employee ID. It's also dependent on department name. Okay, so what we can do is move this, columns that are not fully dependent on the primary key into its own table. So here we are breaking this employees table into two. So employees table here and departments table. So department name and department head, and we have given it a primary key, and then we are using that as a foreign key in this table. So a table is said to be in the third normal form if it does not contain any columns that are not fully dependent upon the primary key. So here annual salary, it's not fully dependent on the primary key, it's also dependent on the salary. Similarly, department head, it's not fully dependent on the primary key, it's also dependent on the department name. In the case of annual salary, you can simply get rid of that because it's a computed column. It can be calculated on the fly. So to bring this table into third normal form, you simply get rid of that column. Whereas if you want to get this table into third normal form, you remove those columns that are not fully dependent on the primary key into its own table and establish relationships between them. So basically, the rules for the third normal form are that they should satisfy the conditions of the first and second normal form, and it should not contain any columns that are not fully dependent upon the primary key. On this slide, you can find resources for ASP.NET, C#, and SQL Server interview questions. If you want to receive email alerts when I post new videos, please subscribe to my YouTube channel. That's it for today. Thank you for listening. Have a great day.